Models and theories are both types of knowledge used in chemistry to improve our understanding of the behaviour of matter as identified through experimental observation. Although the two terms are often used synonymously, there are actually subtle differences that we'll try and address in this video. Let's start with a model. And a model is a representation of matter or its behaviour that assigns a set of characteristics to a system. They are often simplified representations, and they are not necessarily objective truth, but they will always have some useful features and some limitations. This is why we will often have several different models used to try and explain a given phenomenon. Theories, on the other hand, are actual explanations for the behaviour of matter, often using models alongside other chemical understandings. Although the intention of a theory is to be true, as you'll look back in history and see, we often adapt them or sometimes even discard them over time. The key part for a good model or a good theory is that they are supported by those experimental observations. Let's have a look at 3 examples. Let's start with an example considering some observations we might make about liquids. They have a fixed volume, no fixed shape, and cannot be compressed easily. The most common model that we might see to help explain these observations would be the particle model of a liquid. And in this simple diagram, the red particles in the box might be representing atoms or molecules or ions in the liquid state. Of course, this diagram actually is not useful unless we have an accompanying explanation. And in this case, we would consider kinetic theory as being the explanation we're looking for. This uses the particle model we've just drawn alongside an understanding of things like kinetic energy and intermolecular forces to actually be able to explain the observations. Let's consider a second example. In this example, let's consider the atomic emission and absorption spectra. The model we use as the basis for our understanding of these spectra is the Bohr model of the atom. And the explanation that uses this model to explain our observations would be atomic theory. Specific to this example, atomic theory would use the Bohr model and understanding of things like particles, potential energy, maybe even quantum mechanics to explain how electrons are responsible for causing those atomic emission and absorption spectra. So again, my theory is using a model alongside some other conceptual understanding in order to explain observations. Let's look at a final example. In this example, we might carry out an experiment to identify a relationship between the volume and pressure of a gas. Because a graph itself is assigning characteristics to a system, this could actually be considered a model on its own. However, we might take it one step further and represent the relationship between pressure and volume in a formula. In this case, the formula, the model, is also actually a law, but the important thing is it's telling us something about the characteristics of a system. In order to actually explain this behaviour, again we might consider kinetic theory, and this will help explain the relationship between pressure and volume using concepts like ideal gases, particles, kinetic energy and pressure. As a quick summary of the key points, observations from experimental work are explained by often using models, which are representations of matter, and theories, which are proposed explanations, to better improve our understanding of the natural scientific world. Hopefully, this video is of some help.